Hello everyone. I am Udaya, working as Assistant Professor in the Department of Agricultural Engineering at Sri Shanmuga College of Engineering and Technology. So in today's lecture video, we are going to discuss about the topic meteorological measurements. So in this, we are going to discuss in detail about rain gauges. So meteorological measurements are nothing but observing the atmospheric elements like rainfall, atmospheric temperature, wind, evaporation rate. So these kind of measurements comprise and form the meteorological measurements, and it is one of the most important factor for hydrology and water resource engineering. Generally, meteorological measurements are carried out using rain gauges. So rain gauges are simple instruments which is used to measure the amount of rainfall collected at a particular location over a period of time. Generally, rainfall is measured in terms of millimeters. Unit of rain gauge measurements are maintained in millimeters Okay, so there are two types of rain gauges available: non-recording rain gauges and recording rain gauges. So first I'll explain about non-recording rain gauges. As you can see in this image, non-recording rain gauges are a simple instrument which is used to measure the amount of rainfall. So it is used to collect, and we can measure the depth of rainfall alone. This non-recording rain gauge does not record time of rainfall, duration and intensity of rainfall. Only we can measure the depth of rainfall, amount of rainfall collected in a container. Okay, so the commonly used non-recording rain gauge in India, it is Siemens gauge. As you can see in this image, rain gauge is installed above the ground level in a concrete block. And the depth, diameter, it's a cylindrical vessel, metal container. It's a cylindrical in diameter. So diameter of this vessel, it is 127 mm. The overall depth, it is installed below, the foundation is laid below the ground level. So it is almost 1 feet depth. Above the ground level, it is above the concrete block, it is exposed at 210 mm. In this, the topmost part of the non-recording rain gauge, it is occupied by the funnel, and below the funnel a metal collecting bottle is provided. Funnel is generally provided in order to filter any kind of impurities like dust, leaves, so any other solid material that can enter inside the collecting bottle. So for filtering the impurities, funnel is provided, and collecting bottle. So to protect the collecting bottle, metal container is provided. So the main parts of the non-recording rain gauge, as we discussed, a funnel is provided in the topmost part of the rain gauge, and it is generally circular in shape, and it collects the rainfall and it filters and it directs it to the container. Then the outer container, it is a protective layer. It's generally a cylindrical metal body in order to protect the inner container. So outer container is provided. Inner container, it measures the amount of rainfall. So it is generally designed in such a way that in order to reduce the evaporation loss, then measuring jar, collecting bottle acts as a measuring jar. It's a graduated thing. We can measure the rainfall depth in millimeters. So the working principle of non-recording rain gauges, generally rainfall is collected through the funnel. It flows inside the inner container. Generally, fixed observation time is maintained. In India, we are following 8 a.m. Generally, so every morning 8 a.m. People from meteorological department, they used to observe the amount of water collected every day from the measuring jar. The rainfall depth is directly read in terms of millimeters. Installation details: it is installed on the flat ground, level ground. Mouth of the rain gauge, it is kept horizontal, it's always flat, and top of the rain gauge, it is placed above 30 centimeter above ground level. So it is always it should be located in open area away from buildings or trees. So the main advantage is that it's a simple construction, low cost, easy to operate and maintain, and it is suitable for rural and remote areas. So drawback is that it does not measure or record rainfall intensity, duration, etc. And for it requires manual observation. So every day we have to manually observe the amount of rainfall, and it is not suitable in case of detailed storm analysis. So application, generally the rainfall data measured using non-recording gauges are used for measuring daily rainfall, and we can determine the average rainfall over a catchment area, and in case of agricultural planning studies and all, we can use the data observed from non-recording rain gauges. So next we can discuss about recording rain gauges. Recording rain gauges. So unlike non-recording thing, we can also measure the amount of rainfall, duration and intensity of rainfall. It is one of the main advantage. So recording rain gauges further can be classified as three types: tipping bucket, weighing bucket, float type. So each rain gauge, it's having a minor variation as mentioned in the name. So first we will discuss in detail about recording rain gauges. So first one, tipping bucket. As you can see in this image, so it's a overall construction setup of tipping bucket rain gauge. Rain gauge outer container is provided, inside which at the top a funnel is provided not to filter the impurities. The overall diameter of the container is 30 centimeter. It is installed above the ground level. It is inside, as you can see in this image, it is the inside cross section of the container. So bottom portion measuring tube is provided, top portion funnel is provided, in between a tipping bucket is provided. Mainly funnel and measuring tube is provided in the non-recording rain gauges also, but one additional thing it is provided is a tipping bucket. Tipping bucket is directly attached to a chart and paper, and a rod is provided attaching the tipping bucket, chart, drum. Okay, so it's a recording device. So based on the how we can measure the intensity of rainfall based on the force created by the raindrop. Okay, so once the heavy rainfall occurs, the tipping bucket, so here you can see two buckets are provided, it's called tipping bucket. Once the due to high intensity rainfall, one bucket is filled and it tips and go down, the another bucket comes up. Okay, so due to this movement, a force is observed in the rod. So once the rod rotates, the drum attached with the rod, it also rotates. It is with this rotation we can measure the intensity of rainfall. And also a clock, it's also a clock driven mechanism. So based on the using the clock attached with the device, we can note down the time, at what time the rotation begins, at what time a heavy rainfall occurs, at what time moderate rainfall occurs. Based on the movement of the tipping bucket, we can measure the movement of rainfall. Okay, so this is the working principle. Rainfall fills one bucket. So when it reaches the fixed volume, the first bucket tips and the second bucket comes under the funnel. So each tip is recorded electronically or mechanically. Okay, so the output can be maintained in the form of rainfall intensity graph, rainfall intensity versus time graph. Okay, so this, as you can see in this image, this is the real tipping bucket we are in current use. Okay, so it's a simple and automatic, and it is suitable for short duration storms. The limitation, it's like less accurate for very heavy rainfall, and it cannot be used to measure snowfall. For snowfall measurements and all, we will be using non-recording rain gauges. So weighing bucket, next type is weighing bucket. So here the rain collected in a container, it is placed on a weighing mechanism, as you can see in the image. So funnel is provided in the top section. So then a bucket is provided in order to collect the rainwater. So bucket is placed above the weighing balance. So as rainfall accumulates, the increasing weight, here also the same phenomenon. So the measuring rod, the weighing mechanism attached to a chart and pen attached with the setup. So continuous record of rainfall obtained with this mechanism. So here we get the output in the form of graph plotted between rainfall and So the main advantage is that it will give accurate, it will be accurate for all kind of rainfall intensities, and we can measure rain, snow and hail. Its drawback is that it's very costly and it requires regular maintenance. The third type, it is float type rain gauge. As you can see in this image, here also same experimental setup. Outer container is provided, top section funnel is provided, and it's a collection chamber. And here the float is connected to a pen and a rotating drum. So once the rainfall is collected through the funnel, and once it reaches the bucket, here the float movement is observed. Rainfall raises the float. A float is provided in the bucket. So once the rainfall started collecting in the bucket, float will move. Okay, so the float movement records the rotating chart. So with this we can measure the rainfall intensity, duration, etc. So when the chamber is full, here the water is drained automatically. So here the main advantage is that it is used for continuous rainfall record and simple mechanism, but it is not suitable for very high rainfall. It requires frequent emptying. Okay, so I hope this video will be useful for you in order to understand about meteorological measurements, especially rain gauges. So we have discussed in detail about non-recording rain gauges and three types of recording rain gauges, like tipping bucket, weighing bucket and floating type. So thank you for watching. Thank you.